so we'll pick it up where we left off last time, talking about encapsulation and structures. Structures in C and classes in Java, okay? So let's come back over here to where we left it off with our book demonstration, right? What we had done is we had created a few structures here. A book that consisted of an author, a release year, I can increase the size here a little bit, a release year, which itself was, oops, that should be a date, right? Date, there we go. All right, date, release year, which was another structure that consisted of the year, the month, and the day. The author, we separated that out into another structure where we've got author, first name, last name, and date of birth. So we were reusing this structure right here, right? Then we came back over here to the book demo and we started realizing, well, okay, well, how do we actually create a book, right? If you just create a book, right, a variable named b here, right, it's exactly the same thing as creating, say, variable x is equal to 42, right? It knows what you're talking about because it's built into the language with respect to the integer. A book is not built into the language. We built it into the language by defining those structures, okay? So you can go ahead and, manually create stuff. Say, for example, b dot, what was it, rating? Let's see, that's rating here. You can go ahead and go b dot rating is equal to rating. What else can I immediately allocate here? That's it. All right. So how did I access that variable inside the book structure right here? I used this operator right here. Now that operator is known as the direct component selection operator. We won't call it that though, because it looks like it's a period, but it looks like a what? A dot, right? So we call it the dot operator, right? If I wanted to do this for the title, b.title, right, is equal to the title. Is that correct? Right? Remember, these are strings, char star, right? Can you use the equals operator for a string? Nope. So what do I have to do instead? str, cpy, right? Copy into one string the contents of the other, right? Except that have I allocated space for this? So let's go ahead and visualize this and understand what's going on under the hood, basically. So what I want to do is I want to come over here and cut and paste my definitions for all of these structures. And then I'm going to cut and paste that one piece of code where I'm trying to set the rating and set the title here, okay? Now, obviously, I don't have all the code from over there. So what I'll do is I'll go ahead and set the rating to, 2.5, right? And instead of, I don't have a title here either, I'll just go hello world, okay? That's the title of my book. Let's visualize this execution. Now, the first thing I want you to notice is how this structure actually what this structure actually looks like. It's a big giant box, right, that holds data. The title is a pointer to a string. The author and the rating is another box that holds a double, right? But the author here, it's another box within a box, right? We've got this box within a box over here that represents the author because it's another structure. Within that box, we have two strings. And in that box, we have another box. So we've got a box within a box within a box. And we've got a year, month, and day with respect to that thing, okay? Over here, we also have release year. That's another box within a box, okay? So let's watch as we set the rating here to 2.5. That'll simply just update this. There we go, 2.5. Right? Now what happens when I try to copy into title hello world? Well, what's that pointer pointing to right now? Question mark, nothing, right? Have I set memory enough? Have I allocated memory enough to hold the string hello world? How big should it be, by the way? 5 plus 5 plus 1, 11? What do I always do at the end of every string in C? No terminating character, so at least 12 here. This is going to crap out on me, right? There we go. Use of an uninitialized value here. You're trying to copy hello world into a pointer that doesn't exist. So let's edit this code and fix it. If you need a space enough for hello world, what do you need to do? Make a call to malloc. b.title is equal to char star malloc size of char times, and what did I say, 12, right? We'll just go ahead and go, yeah, I'll just go ahead and hard code it here to show you what's going on, right? So we walk through this and we set the rating. We now set the title. Guess what? Now it's pointing to space enough that holds all those values, okay? And when we copy it in, guess what? Hello world has now been copied over there. So that's the problem here. The solution is, of course, to call malloc. So b.title is equal to call to malloc char star malloc size of char times. Now, it's not always going to be hello world here. Instead, it's going to be strlen of title plus 1. Right? Again, y plus 1 for that null terminating character. strcpy takes care of it for me. Got a lot more work to do here, right? We've got to do the rating. Oh, we already did the rating, we did the title. Now we've got to do the author, their first name, last name. We've got to do the release year, but we only have the year here. And so we're only doing partial, right? So we've got a lot of more code to write here, at least maybe another half dozen lines of code. Should I be putting it here? So I'm going to be repeating it over and over again in this loop, right? But it seems like this stuff is like book stuff, right? I want you to create a book given these 5 pieces of data, right? The title, the author, first name, last names, rating, whatever, right? What should this be screaming out to us? Take this code and put it into a function so that you can reuse it, right? That's what we're going to do now. Let's come over here to the book.h file and define the signature for that function. Right? And documentation, of course. This is a factory function that creates a new instance of a book. Why do we call it a factory function? We call it a factory function because we're going to give it these 5 pieces of raw data, and it's going to manufacture a book instance for us. Right? Now, over here in Java, we're going to call that a constructor, and it's a very special type of method. But over here in C, we're just going to call it a factory function because we don't have constructors. All right, I want my function names to have verbs. So if I'm going to create a book, might as well call it create book. Right? What do you need as input to this function? You need the title, const char star title. Why did I make it const? Am I going to be making changes to that string? Nope. I'm going to take it and I'm going to copy it over into that book's title. Const char star author first name. Const char star author last name. You see, this is going to be a lot of boilerplate stuff, right? We call it, we don't necessarily call it CRUD, but CRUD is an acronym with respect to databases: create, retrieve, update, and destroy. And you have a lot of boilerplate CRUD where you have to write all this code just to create a record, to retrieve a record, to update a record, to destroy a record. It's kind of like CRUD in that we are writing the C of CRUD, we're creating something, right? So it's kind of boilerplate code that is not fun at all to write, but you got to write it, and that's why you put it into a function, so you only write it once, and then you never have to do that again, right? What else do we take? Int release year and release year, and finally a double rating, Goodreads rating. Right? All right, now there is a little bit of a difference between my designed structures over here and the data that I actually have. Right? You could say, well, I don't have the date of the birth of the author, so I could go ahead and get rid of that. Or another option would be to redesign this function to require the date of the birth of the author, right? Or another option, probably better than both of those, would be to write multiple factory functions that allowed the user to use those factory functions however they wanted. One of them would be these 5 pieces of data. One of them would require a 6th piece of data. One of them would require maybe just these 2 pieces of data. We don't have the author or something like that, right? Or we don't have a rating. So we'll just go ahead and use a sensible default. you're not limited to just one factory function. Okay? What's its return type going to be? This is a good question. How should we design the return type here? A what? Okay, we could do error handling, and then I would have to return the book by reference. Unfortunately, I'll give you a book B, right? There is a book over there. Go ahead and initialize its values, right? But that puts some of the work on me now because I've got to allocate space for it. That is an option. We'll talk about that later. Right? But in this case, I want to return the book. Right? So my return type could be, well, if I were doing error handling, I would return an integer, right? Book is now a defined type. I could return a book. Right? But now think about the consequences of this. This big giant box, if I return it by value, right, I am taking everything in that big giant box, I'm copying it onto the stack, and then I'm passing it back to the function, who then copies it again to their local copy, right? Not that big of a deal. This is not that big of a box, less than 50 bytes likely, right? But it seems kind of icky. That's not the C way, right? How many people have Python background? All right, 1, 2, right? Have you ever heard the term, you can do it that way, but it's not the Pythonic way? Have you ever heard that term, Pythonic way? Right, yeah. So if so, like, yeah, you can do it object-oriented. Yeah, you can do it kind of a C imperative style, but that's not the style of Python. Do it this way instead, right? This is not the style of C. The style of C is you have access to low-level memory, pointers. Use them to the fullest. So I'm going to return a pointer to a new book. I'm going to tell the calling function, there's your book over there. I'm pointing to it. I created it for you. Right? Now that puts all of the work on this function, because what is this function going to end up looking like? The implementation, that is. Right? By the way, before we implement this, what else did I do there with all my values? I wrote them in a different style than we're used to. Right? I aligned them all vertically, one to a line, right? That's perfectly fine. That's white space, right? Who cares? But why did I choose not to put them all on one big line? Right? What are you going to end up doing? Scrolling back and forth every single time, right? Whereas if it's a list, a vertical list, it's way easier on the eyes to read. It doesn't take up much real estate on your screen, etc. Right? So if you want to follow that style, great. If you do, however, you're going to want to nicely vertically align all of this stuff. Some people get really pedantic and then also align the variable names. Right? And they just get it just so. And then when they go and copy and paste it somewhere else, it gets all screwed up and they have to start over. Right? Some of them might like a white space right there as well, right? Et cetera, et cetera. I wonder what A style would do with this. Remember that old tool that we've used before, but you don't need anymore because you write nice clean code from the beginning, right? Hopefully, book.c, right? And let's see how that changed it. Oh, it didn't. All right, it doesn't care about our white space. All right, fine. Okay, so how do I create a book here? If I create a book, B, can I return that B? Well, first of all, that's not the correct type, right? That's a local variable. Where does it exist? It exists over here in the stack frame, right? Just like if I had a static array, can you return a static array? Not if it exists in the stack, because what happens to that stack frame when you return from a function? Popped off and destroyed. Besides, the return value doesn't match here. I need a book star, okay? What I'll do here is to do basic error checking. Right? And what that means is going to be, it really depends, right? Is the title required? If so, then it can't be null. Maybe you also say that, well, it can't be empty, right? It can't be a string of size 0 where there's no characters in it. Maybe the author is required. Well, some authors only have a last name or a pen name or something like that, right? So to do basic error checking would be, I don't know, Goodreads rating. That would seem correct. That you could, it has to be between 0 and 5, right? You could do something with that. I'll leave that off as a to do, because I don't know. Sometimes the requirements are not all that clear. You have to go back to whatever stakeholder wants you to write this stuff to begin with, and say, look, what happens if there's no rating? What happens if there's no release year? Because it hasn't been released yet, right? Game of Thrones, the last one, right? What if there's no author first name? What should we be doing here, right? Those aren't errors. Those are valid data, right? All right. So I'll leave that as an exercise. Book B. How do I create a book? Well, I'm creating a book right now. But how do I create memory for a book? How do I create memory for anything? malloc, right? And the returned value from malloc is going to be a void star pointer. When we wanted an integer array, we typecast it as an integer array, int star. When we wanted a string, we typecasted it as char star. We don't want those things now. What we want is a book pointer. So what should I cast it as? Book star. Right? Once you've created a structure, right, it's part of the language as far as the compiler is concerned. Right? Int, double, char, those are the built-in types. Once you've defined your own, it becomes basically the same usage as those built-in types. All right, well, how many bytes do you want? I could do an exercise over here where I go in and say, all right, well, a pointer is 8 bytes. So 8 times 3, 24 right there. These are 4 bytes each, so 4 more, so 12 more. What am I up to? 36. Another 12 there, another 8 there. So that's 20. So 56. That's not how you do the math, right? If you wanted a character, you'd go size of char. If you wanted an integer, you would go size of int. You don't want those things. What do you want again? A book. How many of them do you want? Just one. Right? Strictly speaking, you don't have to put that in there. Okay? Because why? X times 1 is X. Right? I'll go ahead and leave it off. Now I've allocated enough memory for the book. Have I allocated enough memory for the title? Not yet. That's what I do next. I'm going to go ahead and steal some of the code from over here and bring it over here to book. And okay, well, the rating, I can go ahead and set that, but generally you order things in the same order that you order them up here. So I'll do the rating last. I'll do the title first here. B.title, ... the title. All right, that looks good. Let's do some ad hoc testing here. Let's do some ad hoc compiling. GCC C book.c. Right? This is going to fail. Oops, it's going to fail for another reason. Oops, there we go. All right, now it's going to fail for the reason that I wanted it to fail. There we go. Right? B is a pointer. Did you mean to use something else? Right? So think about B right now. It's a pointer. If you're going to use the direct component selection operator, the dot operator here, you have to change it into a regular old variable. Right? So this is a pointer variable. How do I change it into a regular old variable? I have to dereference it, right? It makes a pointer into a regular old variable. I use the star. Now, if you open up your big book of PEMDAS, you will find that the dot operator has a higher order of precedence than the dereferencing star operator here. So this is still not correct. And what we have to do is we have to surround it with a parentheses here, because now PEMDAS, the P in PEMDAS, right? We've elevated this to the first thing that it does. This is going to be correct. But parentheses, dereference, dot, right? C has added some syntactic sugar so that you don't have to do this, right? Or sorry, B and then hyphen greater than. That is known as the indirect component selection operator, but we're not going to use that name either. What does it look like? An arrow, right? Why? Because B is a pointer, right? And so consequently, we're going to use the arrow operator. In fact, that's what it was asking. Did you mean to use the arrow operator? Yes, I did, right? And so anytime I've got a pointer to a structure, I am going to use the arrow operator instead. Now I can go through the rest of this stuff. Copy paste for the author name, right, except for, okay. I need to remember that the author is another structure here, right? And when it's a member variable of the book structure, it's called lowercase a author. So I want to access the author, and then I want to access their first name. Dot or arrow here? Which one? Dot or arrow? To their first name. Let's come over here and look. Oop, you know what? I'm going to rename these now. First and last. Because it's already in the author structure. You don't want to have author first name, right? First name. There we go. First name and last name. Right? Except that what kind of variable is author when it's inside the book structure here? It's a regular old structure, right? When I've got a regular old structure, which one do I use? The dot or the arrow? The dot, right? I could have changed it, right? I could have done something like, let's go back over here. I could have said, I don't want an author, I want a pointer to an author. And then I would have to use the arrow operator. Half a dozen of one, 6 of another, right? However you want to design it, okay? Otherwise, there's the first name, author first name. Lots of boilerplate, right? Unfortunately, there's no other easy way of doing it, except that I could cut down on a lot of code here, right? I'm doing a lot of string copying. Copy that allocate memory for that string, copy that string. Allocate memory for that string, copy that string. Is there a better way? Anytime that you're doing one thing more than once, what should you be thinking about doing? Putting it into a function, right? A deep string copy function, right? Otherwise, the release year. Okay. Remember that B is a pointer, so we need to point to its release year, which is a date, right? Which is a regular structure, and that regular structure has a year in it, okay? B, release date, what did I call it? Release date? Or release, yeah, we should call it release date, because it is a date now. Release date dot year is equal to release year. There. I've successfully created a factory function for books. Right? Now over here, all I ever have to do is not worry about those details. All I need to do is call that function, create book, title, author first name, author last name, year released, and rating. There we go. Let's make sure that everything compiles before we move on. Oops. What am I not doing over here that it's complaining about? I don't know anything about strings. Okay, I'll tell you about strings. stdlib.h and string.h. Eventually we'll probably want the stdio library over here as well as we continue building this thing. So I'll go ahead and add it prematurely here. Right, there we go. Oops. Oh, you know what? It was probably a copy-paste error from over here. There we go. Right. That's a good gotcha right there. All right, I tried to compile book.c, and it says error const before line 26 here. Oh no, it's telling me in the header file. Okay, so it's being very generous in telling me exactly which line in which file that I should be looking at here, and that was the missing comma right there. Okay. Oh, another good question here. A style on book.h. Will it fix that indentation? Let's find out. Ooh, it did. Nice. Cool. See what it did? It was not fully indented because I had gone back and added book star to it, and A-style fixed that for me. Cool. All right. Let's go ahead and compile everything together. Book.o and book.demo.c. All right. I need to include my new library that I'm building here. Include book.h. There we go. Uh-oh, create book. Undefined reference to create book. Did I not call it create book? What did I call it? Book, create book. Book, create book. CCC, C, book.c. Okay, I must not have recompiled or something. Sorry. Anyway, there's a dot out, working as it was before, but we're actually not using our book class, or our book structure yet here. So let me go ahead and do that. Let's replace this code. Right? Let's replace it with a way that we can print out a book, right? Before we move on to say Java, right? And then we'll of course come back to this. We've got a lot more framework and scaffolding to build here. I don't want to have these 1, 2, 3, 4, 5, 6 lines of code every single time I want to print out a book. So let's write a function to do it. I could have a function called printBook that prints it to the standard output, right? Prints the given book to the standard output. Right? Or what's another alternative here? I could have a book to string method that converts, returns a human readable representation of the given book. Right? There we go. Which one is more powerful, or which one is more flexible? Right? To string, why? Sometimes we can print to the standard output. Right? Sometimes we don't want to necessarily print to the standard output. We want to print to a file. Sometimes we want to print to another string. Sometimes we want to print to a socket to send it over the internet, over the network or something like that, right? So if we have a generic toString method here that returned a string representation of that book, then this function could use that function, right? But also we would have this function in reserve to do other things with it. Let's write both, right? This one's not going to return anything. It's just going to take a book and print it out, except is this the C way of doing things? Passing by reference, or passing by value versus passing by reference, right? Okay. Am I going to be making changes to that book if I'm just going to print it out? Nope. If I'm not going to be making changes to your array, I put a const in front of it. I'll do the same trick here. Remember, const int star array, right? Int is just a built-in type. Book is now a built-in type, a user-defined type. So I can do the same tricks as before. Same thing over here. There we go. Now let's implement both of these, okay? Over here in the book source file. There we go. All right, it doesn't matter which one I start with. Let's go ahead and start with print book here. Right? So I want to print it to the standard output, but I already have, suppose that I've already implemented this function over here. So let's call it char star s is equal to book to string book, right? Let's print it out. Printf %s and the line, right? S, right? And then return. Right? All I'm doing is using the functionality that maybe somebody else writes this for me, right? Or maybe I was given it, right? Or eventually I'm going to have to write it myself, okay? All I'm doing is reusing that functionality here, printing out whatever string it creates, and then I return. Now, is there a potential problem here? Problem. Let's go back over here to Python Tutor. Where do these strings exist? Where do things that have been dynamically allocated by malloc exist? Over here in the heap, right? It exists in the heap. What is Valgrind going to tell me if I run this as it is right now? Memory leak, right? This character array right here, this string, has been leaked. You asked for it, it allocated it, it created it for you, you printed it out to the standard output, now you're done with it. Once you're done with it, what should you do with it? Free it up. Right? Now there's no memory leaks. Right? Free it so there are no memory leaks. Right? That's good. Okay. All right, book to string. Char star s is equal to a call to malloc, char star malloc, size of char, right? And ooh, how big? How big? There we go. You can do something like that. Hopefully it'll complain about it, but that's just pseudocode for me right now, right? How big do you want it? Well, if you want this formatting, what are you going to have to do? You're going to have to go in and count the number of characters there. You're going to have to count the number of characters there plus the number of characters in the title, right? I don't want this formatting anymore. What I want it to look like is something more like this, right? Printf title by %s, last name, comma, first name, released in %d with a rating of %f. And then we'll leave it like that, okay? So I'm going to print out the title. How do I get the book's title? B's title. So what do I put right here? B is a pointer to a structure. Do I use the dot operator? Or do I use the arrow operator? Arrow operator. Right? B's title. B's author dot last name. B author dot first name. Right? B what was it? Release date dot year. Right? B reading. There we go. Very long line. You can go ahead and break that up if you want to. I'll just go ahead and leave it as it is though. Okay. Now, this is printing it to the standard output here. Right? Okay. That doesn't, I don't want to print it to the standard output. What do I want to print it to? Well, what do I want to return? A string. Do I want to print it to a file? No. I don't want to print it to the standard output. I want to print it to a string. Do you remember sprintf? Right? I thought we covered it, didn't we? All right, we did? Okay. All right. Well, how big is it going to be? I don't know. Let's just go ahead and say that it's going to be char s is 1000. Right? And then we'll return s. Am I going to be, oh, by the way, and then sprintf, I actually want to print to s. Is this going to work? GCC C book.c. The compiler hopefully will complain about this with a warning, a very strong warning, right? Because, all right. Again, I'm forgetting my commas today for some reason. There we go. Warning, and that's a very strong warning. The function returns an address of a local variable. This is a static array. Can I return a static array? For the dozenth time, no. It exists on the stack. The stack frame is destroyed when it gets popped off after you return from the function. This goes away. But wait a second. I don't want to have to do a lot of work. I don't want to have to go through and count up the number of characters in the title plus space by space, so +4, plus the number of characters in the last name, plus comma, so we're 5, 6, right? I don't want to do this math, right? Besides, if I ever come in and I change it, right, and add, was released, right? Now my math is off again, right? All right, so what I'm going to do is I am going to use this, but I'm going to use it as a temporary workspace. Remember when we did like remove space or remove all white space or something like that? We did a trick where we said, let's temporarily create a string big enough in order to use it as a temporary string for our work. And then when we're done, we'll go ahead and copy it over to the final one. We'll do the same thing here. I'll use a static string that is big enough for any reasonably printable book, but then when I'm done, I will create the final string here, char result is equal to char star malloc size of char times strlen of s plus 1. Make sure that you've got good math. Oops. There. Now, str cpy into the result s, and we don't return s now, we return result. This warning now goes away because we are returning dynamically allocated memory instead. Okay. What happens to this though? Do we need to free this up? Nope, because again, it's in the stack. It'll get popped off. It'll get cleaned up for us. In fact, it would be very bad if we did that. Right? This is bad. Think about what you're doing here. In fact, yeah, free call in an unallocated object S. Right? It's just a warning. What we're going to get if we run this is a stack smashing event. You can't free your own stack, right? You can't destroy your own stack. That's like pulling the rug out from under you. You're going to fall. Right? So this is very bad. Right? You cannot free your own stack. Right? So I'm going to go ahead and get rid of that. The warning goes away, and we're all good again. Right? Let's come over here to the book demo. And I was printing it out over here before. Let's now go ahead and print book B. Sorry, there we go. And bring everything together. A.out. There we go. Game of Thrones, Harry Potter, all the way down here was the highest rated book. Right? Getting a little bit better, right? This is a little bit cleaner code now because we can create a book here. We could store it into an array of books, which is what we'll start talking about next week. Right? But otherwise, you can create a book from the above data. You can print it out. You can do a whole bunch of other stuff. Okay? Let's come over here to Java and create a book class. Right? We only have about 12 minutes left, but I can guarantee you that I could do this in 2 minutes. Right? But I'm going to slow it down. Create a class. Over here, we're going to use the same naming convention, capital B, lowercase o, OK, because it's upper camel casing. Finish. Right? Define what a book is. There's a title, right? So we'll come back to the private keyword here in a second. String title, right? There we go. Private string, or, oh wait, an author. Author, okay. It doesn't know what an author is. What should that tell you to do? New, class, author, right? Well, what's an author? Private string, first name. Private string last name. And let's go ahead and mirror what we did over here in C, where we've got an author's date of birth. Right? So private date of birth. So does it know what a date is? Nope. So before we jump to the last conclusion here and create our own class to represent dates, the other question you should ask yourself is, does something already exist? We didn't create our own string class. We didn't create our own integer type. Why should we create our own date class? It's built into Java. It's called local date for a reason, because it's not the same date all over the world at all times, right? So whatever if I took this program and I moved it over the international date line, the same program run at exactly the same instance in time would have different dates. That's why we call it a local date. It's in the Java time library. Right? So don't make your own. Don't roll your own if there's something that already exists in there for you. Okay? All right, go back to book now. Now I've got an author. What else do I have? Private, what was it? Release date and rating. So again, local date, release date, and private double rating. There we go. I do have to import this from the java.time library. Excellent. Now, what I did over here in C was create a factory function, a print function, and this toString function. The wonders of modern technology. I don't have to write a single damn line of code. Let's see, source, generate constructor using fields. Over here in an object-oriented programming language, we call those factory functions constructors. Well, which ones do you want? All of them. Done. Right? It even put on some documentation for me. Right? Great. I want a toString method. Source, generate toString. I want to include everything. All right. Now, unfortunately, that's the default generated code for how it gets formatted. I don't like that. I'm going to steal my formatting over here. I want to use this formatting, the same exact formatting. Okay. But to do that, I don't use sprintf. Instead, I use string.format, right? And I return that string. There we go. And of course, I don't use arrow operators because I don't have pointers. Instead, I have title. What else is there? Author. Release date. And rating. There. And then end the line. All good. Now it is going to complain because the author here is just one thing. Right, there we go. All done. Right? Most of the code was automatically generated for me. Let's come over here to the demo and replace, or add, I guess, a new book, just like we did over in the C version. Book B is equal to new book. To invoke a constructor, that's where the new keyword comes in. We've seen this before when we created, say, new lists, new sets, new arrays, etc., etc. I just want to create a new book here. And I'm going to pass in the things that I have. Title. Author. I don't know. Do I have an author here? No. Year string. Or not year release, sorry. Oh, I don't have that either, right? That's a date. And rating. All right. Well, I want those things. I want the author, A, and I want the release date, which is a local date. Right? Release date. Right? I want those things because I want to be able to give them off to this constructor over here. A and release date. Come on, I don't want the question marks anymore. There. Once I import this, it'll compile, right? What are you complaining about? Oh. What did I do? Why did it make it private public? We'll come back to private, public, and protected here later, but that was auto-generated. It should not have done that, right? Release date, what are you complaining about now? Okay, it's uninitialized, right? So I do have to initialize them. How do I create a new author? I want to create a new author given their first name and their last name. Oops. Okay. But there is no constructor that takes those two things. Why? Because I didn't write one. So let's do that. I'm not even going to write it, right? I'm just going to go up to source, generate constructor using fields. Now before I click next and generate, I only want one with the first name and the last name. I don't want the date of birth, right? Because that's not the data that I have. Uncheck it. It will not generate it with that thing, expecting that thing. All right? Let's quickly write that toString method as well, toString. Except that, remember, I don't want the date of birth in there. I just want their last name, comma, first name. So we can go ahead and click that off, right? And it'll have first name is equal to, last name is equal to. Again, I don't want that formatting. What I want is the last name plus a comma, space, plus the first name. And that's it. All right. Let's come back over here to demo. Did it generate it private again? Why is it doing that public? I must have changed the default setting somewhere. All right. Here, release date. I didn't write that. Had I written it, I would have written it so that it had a constructor. Unfortunately, they decided we don't like, whoever designed this decided we don't like constructors. We like factory methods. Local date dot of. And then you can go ahead and provide it the year, the month, and the day. The year, the month, and the day. Of the year, I don't know. It looks like you're required to do all of them, though. So, I don't know. We don't have that data. We do have year released, but what do we do about the month? I could go -1 and -1, right? Month and day. Then it would throw an exception because that's not a valid date, right? So, I don't know. If it was released anytime in the year 2007, we'll just go ahead and say 1/1, January 1st as a default value. Okay. Ultimately, we're not even going to print that out, so we don't care. If we need to, we can come back to our data, update it so that it has a full date. I don't know. Okay, there. Instead of just a release year. Okay. Or we can go back and say, well, okay, I don't want a local date, I want a local year, right? But there is no such thing built in, so we'd have to write our own local year. Oh. At least I don't think there is. No, there is no such thing. There we go. All right. Now I've got my book. Let's go ahead and print it out. System.out.print ln b. Now, if this was successful in 5 minutes, we just duplicated about an hour work in Java that took us an hour or so in C. Right? Formatting thread. All right. B local date. Yeah. We can't print out the local date. What do I need then? I need the release date dot year. Get year. There we go. I need to get its year. Because I'm not interested in the month and the day, I'm just interested in the year here. There we go. Harry Potter and the Deathly Hallows through Game of Thrones, with Harry Potter being the highest rated book. Right? So, all that boilerplate stuff that we did over here that required memory management, that required thinking about how to do it, over here, it only took 5 minutes because 90% of the work was done by the IDE itself. Source, this is the boilerplate in Java. Right? Getters and setters, we'll talk about those next week. Hash code, toString, constructors, right? All you need to do is generate that data, change it, massage it if you want it to look different, right? But otherwise, it automatically generates that stuff. Other things that we'll look at next week is, what the hell is this? Right? What is super? Right? You don't need super. I'll go ahead and get rid of it. Right? What if you just wanted the title? Right? Could I just print out the title? B dot title? That doesn't work. Maybe it's more like C, where I've got a arrow operator title. Nope, that doesn't work either. Right? I wonder how we can do that. Well, once again, you generate getters and setters. Right? We don't have enough time to do it, though. Right? Any questions? No? Then we'll pick it up and continue there next week. Have a good weekend.